The book is aimed at the so-called creationists who spent a lot of time discrediting Darwin and trying to dissuade schools from teaching evolution. You don't see hardly any of this in Canada. I mean, is this group even large enough to be bothered with?
It is undoubtedly large enough to be worth bothering with in the United States, and that's a pretty important market. It's not negligible in Canada, I suspect. It's not negligible in Britain. Largely, I think, through ignorance. I think it's 28 or 27% of the British population think that humans coexisted with dinosaurs. That's
and the percentage that you're saying, too, is not just people who say they believe there's a God that creates larger meaning, but you have, I think, 44% of Americans saying that man was created in his current image within the last 10,000 years.
Which is an astonishingly erroneous idea. It's not just slightly wrong.
No, and you call these people
wrong.
History deniers, and almost as if there's an analogy there to Holocaust deniers.
Well, I make that comparison explicitly, and I gathered since that it's rather a sore point. I don't quite understand that. I mean, both of them are history deniers. Both of them deny the manifest facts of history. The evidence for the Holocaust is overwhelming. The evidence for evolution is overwhelming. Both happened in the past, so you can't actually see it happening before your very eyes. In the case of the Holocaust, we do, of course, have eyewitnesses, but eyewitness evidence is not the most compelling evidence anyway. In the case of evolution, there's a certain amount of eyewitness evidence, but obviously, and I've got a chapter on that called Before Your Very Eyes, but eyewitness evidence isn't the only kind of evidence, and I use the analogy of the detective coming on the scene of a crime after it's happened. So you can't actually have any eyewitness evidence. You can't see the crime being committed. But the evidence that's been left lying around in the form of fingerprints and footprints and DNA samples and things like that is there. And that's what we have in the case of evolution. And it is totally overwhelming. It is at least as strong as the evidence for the Holocaust. Both are history deniers.
Before we get into that evidence, because I know our viewers will find it fascinating in its own right, I mean, we make a point that one of the problems of providing a proof of evolution rests in the very notion of what is a theory.
Yes.
Explain that to me.
Well, the word theory is rather a pernicious word because it has two rather different meanings. To a scientist, theory is something like the heliocentric theory of the solar system, or the theory of gravitation,
right,
which is not the same as the colloquial meaning of theory, which is sort of something more akin to hypothesis, something that is just a kind of guess, and it might be true and it might be false, and nobody's ever proved it. Hence the phrase, evolution is only a theory. Where's your evidence? You've never found the missing link, etc. Prove it. It's not that kind of meaning of the word theory. I don't know if this is deliberately deceptive misuse of the word theory. Probably not. It probably just stems from ignorance.
So for you, I mean, the theory of evolution is basically an explanation supported by evidence.
Yes.
In all your work, what is the single most overwhelming piece of evidence for you documenting evolution?
It's very hard to choose one because it's all so strong.
Like the detective. It's finding
That's
all the pieces together.
Like the detective. I suppose one thing I would say is that fossil evidence is not the most compelling evidence. Fossil evidence is very compelling, but it's not quite the most compelling evidence. I suspect the most compelling evidence would either be the evidence from geographical distribution. The detective finds that the distribution of animals and plants over the islands and continents of the world is exactly what you'd expect.
Expand on that, because this is very interesting. The whole notion that the tectonic plates and continental drift provides fantastic evidence for evolution.
Yes. If you think about how the animals and plants should be distributed if God had put them there, there seems no obvious reason why God would have deliberately put animals and plants on islands and continents in such a way as to make it look as though they'd evolved. So Darwin, for example, looked at the Galapagos Islands and noticed that the animals there are recognizably of a South American type. They're sort of pretty good affinity to South American animals, but they were different enough that you could none of them were actually the same as South American animals. And moreover, even on the different islands within the archipelago, they were somewhat different. And everything fell into place when Darwin later realized that it could be explained if you assume that a rare individual, or pregnant female or something of that sort, of a few individuals perhaps, drifted across from South America in a very rare event. I mean, the sort of thing that only happens once every 1,000,000 years or so. It's very rare. And then once they got there, they then started to change and modify themselves.
They evolved quite uniquely because of the geographic isolation.
That's right. And then if you look at the different islands within the archipelago, where the distance apart is a matter of tens of miles rather than hundreds of miles, they're much closer to each other. And so once again, you have rare drifting from one island to another, but not so rare, because 20 miles is a lot easier to drift across than 600 miles, which is the distance from South America.
But there is a reason there are no platypuses in Canada.
That's right, and that you find them only in Australia.
Only marsupials in Australia, basically.
Pretty much so, yes. Now, there were marsupials in South America, mostly extinct, but one or two remain, like yapox and possums, and some of them even got into North America. So the distribution of animals is precisely what you'd expect if a rare immigrant got in there at some early point.
You stated that fossil evidence isn't necessarily the most compelling, but certainly probably the most familiar to our viewers. Explain how fossil evidence works, and why, again, the ordering of where fossils are found in different layers of the Earth's crust. Tell us something about evolution.
We are very, very lucky to have any fossils at all. It's a remarkably fortunate phenomenon, fossilization. But most animals that die never fossilize. Most species that die never fossilize either. So we have to look at it as a sort of rare, privileged trace of the evidence from the past. Now, there are, of course, gaps, because, as I say, most species, most animals don't fossilize. So there are huge gaps in some places, small gaps in others. You cannot expect the fossils to provide you with a kind of cinematic replay.
Frame by frame of the entire story.
Most of the frames are missing. It's
Right.
like a film in which only 1 in 1,000 of the frames of the film are still there. However, what you can say is that not a single fossil has ever been found in the wrong place.
Now, this is a very important point you make,
Yes.
because not only does the fossil evidence kind of taken together point to evolution as a fact, but you say because of that is that evolution is calculatably falsifiable.
Yes.
That you could prove evolution did not take place if you found something in the wrong...
It would be so easy to disprove it if only you found something...
You found a rabbit in the Precambrian, for example.
that was J.B.S. Haldane's famous example. And no such thing has ever been found. There are one or two fraudulent, obviously, cases, or not fraudulent, but mistaken ones. For example, in the Paluxy River in Texas, there are dinosaur footprints, and they're genuine dinosaur footprints with 3 toes. And there are also what look very, very vaguely like just sort of one long footprint that they've interpreted as human footprints. I mean, they'd have to be a footprint of a giant,
right?
Huge. But that's okay, because in Genesis it says there were giants in those days. So for a long time...
You're quoting Genesis now on me?
Genesis says there were giants in those days. So that's why they like it. But in fact, these are just dinosaur footprints without the 3-toed, without the 3 toes. And even the creationists have stopped saying these are human footprints.
Well, I want to talk about the creationists, go back to them a little bit, because the existence of fossils are undeniable, and that they have found fossils that clearly show that, you know, that different species have taken different shapes in different periods of history. You talk in the book about an explanation of the layering of fossils related to Noah's Ark that might be interesting for some.
It's an observation that before a certain date, if you look at vertebrate fossils, you find nothing but fish, and then a little bit later you find nothing but a slightly more advanced kind of fish, and then a bit later you find amphibians, a bit later you find reptiles, a bit later you find mammals, and so on. And so there seems to be a kind of progressive layering as you go up the fossil strata. And on the evolution idea, of course, it's obvious why that is. There is a creationist theory that says, oh, well, in Noah's Ark, the cleverest and brightest and nimblest of animals headed for the hills when the waters were rising, and so they came to the top. And so mammals climbed higher up the hills when the waters were rising, and amphibians were lower, and reptiles...
And that's why the order that we find in the fossilized records.
This is sometimes described as an ingenious idea. I think that's a bit of an exaggeration, really. I mean, one thing you could say about it is that on that theory, you would expect to find lots of exceptions. You might just about find a statistical tendency for the brightest and cleverest animals to be higher up the slopes of the hills. But you wouldn't expect to find that there's not a single exception. You wouldn't expect to find that not one single solitary mammal drowned before it could get to that appropriate level on the hill.
There wasn't a stupid human or a stupid mammal in the group. Now, for as long as I've lived, I mean, the contrary argument put forward to evolution is, where is the missing link? Where's the Frankie? Where are all these things that, you know, should be in transition between something that used to be and something that we know today? You make the point is that, in fact, there's tons of missing links out there. We've got a whole bunch of them.
Yeah, tons of missing links and tons of missing links that have now been found. In particular, I mean, the phrase missing link is very often used specifically for human ancestors. And at the time when Darwin wrote, there were no human fossils. Now there are lots. In Africa especially, because that's where the story of human ancestry was played out. There are now lots of fossils. Some of them are very beautiful. You can see them in museums in Africa and elsewhere in the world, often replicas elsewhere in the world. Now, Frankies, that's another order of stupidity, that particular phrase, that particular word. This is the idea that why isn't there an intermediate between a frog and a monkey? Or the other one is a crocoduck. Why is no intermediate?
Right.
That monkeys are not descended from frogs. I mean, monkeys and frogs are cousins. They're contemporaries of each other. You wouldn't expect to see a Frankie anyway. You would expect to see, or a crocoduck, you would expect to see intermediates between older fossils and younger fossils, and those we do see. We see them in the human record, we see them in the horse record, we see them in the whale record, we see them abundantly in mollusk and arthropod, crustaceans and things like that records. We see plenty of intermediates between old fossils and young fossils. We see medium-age fossils in between. That's what you expect to see. You do not expect to see intermediates between one modern animal and another.
On the monkey front, is that I think this also affronts some of our kind of modern conceit about being a human being. That, you know, we can't be evolved from monkeys. I mean, you make the point that our evolution is a little bit more diffuse than that direct line. Tell us a little bit about our family tree, our evolutionary family tree.
If you go back some 25 million years to see what our ancestor would have looked like then, it would have looked pretty much like a monkey. So we're not descended from modern monkeys. Modern monkeys and we are descended from older animals, which were much more like modern monkeys than they're like us, and so it would probably have been reasonable to call them monkeys. We are not descended from chimpanzees. Chimpanzees are descended from the same common ancestor as we are, which lived about 6 million years ago. It would have looked more like a chimpanzee than like a human, but you wouldn't call that a chimpanzee by any means. It certainly wasn't a chimpanzee. So I think it's a matter of how you use language. There are some times when you say, well, the ancestor of fish and ourselves would surely have been called a fish. It would have looked like a fish and tasted like a fish. So it's reasonable to say we are descended from fish. But once again, we are not descended from modern fish. Modern fish and we are descended from ancient fish who are no more.
The other thing I think that people have some problem with is that the time span is almost inconceivable when you talk about being evolved from a fish. But you mentioned you have a chapter here, kind of before our very eyes, that there's evidence of evolutionary change happening in species in a very short period of time all around the world. Talk to me about some of those examples.
Okay, I mean, the biggest barrier to understanding probably is the sheer enormous length of time. And so it's valuable that we do have some examples before our very eyes. Inevitably, however, they have to be relatively small amounts of change, because before our very eyes is a timescale of decades. And so we can't expect to have too much evolution going on in that time. Nevertheless, what we have is impressive. I quote an example of lizards on Mediterranean islands, where experimenters about 35 years ago transported lizards from one Mediterranean island to another.
This is around Croatia.
Yeah, that's right. And just left them there. And then another group of researchers went back to the island 30-odd years later and found that the lizards had changed in an interesting way. They'd moved towards a more vegetarian diet. So on the original island they were insectivores, and they moved on the new island to become more vegetarian, which influenced them in all sorts of ways. Their jaws became wider and stronger, the gut changed. They developed valves in the gut which are suitable for a vegetarian diet.
That they didn't have previously when they were insect eaters.
Previously. So this is in a matter of a few decades.
The tusks on elephants.
Tusks on elephants, that's a less clear case. The elephant life cycle is very slow. It's very, Darwin actually used it as an example because it's legendarily slow turnover. But if you look at the records of shootings of elephants in Uganda from about 1928 to about 1958, another period of about 30 years, you find that the tusks get smaller and smaller as the decades go by. Now that looks like a natural selection effect because both poachers and legitimate hunters would have been going after the biggest tuskers for their ivory. And whether it's actually an evolutionary change is less clear. It could just be that we're seeing natural selection itself, the decimation of the big tuskers, and so that's why the average tusk length goes down. And no doubt it will have had some genetic impact on the gene pool of the population, but it may be that we're not seeing that so much. I suppose the best example I've quoted in the book is the example of bacteria, because unlike elephants, which have a life cycle measured in decades, bacteria have a life cycle measured in minutes.
So and you can see evolution in E. coli, for example.
That's right.
The human embryo you also cite as a very interesting example.
Yes, I mean, my chapter on that is about, it really takes off from a famous story, again, about J.B.S. Haldane. After a lecture, he was once challenged by a lady who said that she simply couldn't believe that something as complicated as a human could have evolved from, in those days she would have said an amoeba, one wouldn't say that anymore, even given billions of years. And Haldane said, "Madam, you did it yourself, and it only took you 9 months." So that's the lead-in to my chapter on embryology, which is a bit of a peripheral chapter, but it's sort of showing partly that embryos, including human embryos, have vestiges of past organs like gills. That's been well known, and tail and hair and things like that.
Well, that's an interesting lead-in to, again, a major part of the whole notion of intelligent design is not simply the majesty and the awe, but the perfection. I think someone said, you know, the notion that this happened by accident, as if a whirlwind came and picked up debris and reassembled a jumbo jetliner. You talk about unintelligent design, examples in nature that don't make much sense at all. For example, the larynx of a giraffe. Why is this important to you?
If it had been designed, then an animal would look as though it had been perfect from the start. It would not show evidence of error. There are numerous examples in animals of the legacy of history. There is a nerve in mammals which supplies the larynx, the voice box, and it starts in the brain, and it goes. What it should do, if it was well designed, it would go straight to the larynx. That's what it's for. In fact, what it does is it goes down into the chest, loops around a major artery in the chest, and then goes back up to the larynx. Well, in a human, that's a bit of a detour. In a giraffe, it's a 15-foot detour. And I've actually taken part in a dissection of a giraffe's neck in order to find it, and we found it. And sure enough, it goes right past the larynx on its way down, goes within an inch or so of the larynx, and it could so easily, any designer worth his salt would have simply stopped it there, because that's where it's going. Instead it goes down into the chest, 15 foot, loops back up again. That's a beautiful, elegant example of a piece of bad design. It works. Tinkering after the event no doubt cleans up the mess, but it's not the way a designer would have made it. And I found, looking at that giraffe stretched out on the operating table, it was, to me, a very eloquent testimonial to the fact that either there's no designer or he's a very bad designer. The form of the animal is the way you'd expect it to be if it had been evolved by gradual degrees from a historical origin, rather than if it had been an engineer sitting at a drawing board and saying, "Oh, no, that design won't do, we'll toss it away and start again." An example would be the tube that leads from the testes in a mammal to the penis. The most direct route is not taken. Instead, the tube goes up loops its way around another tube, the one that leads the urine from the bladder down, from the kidneys to the bladder, loops its way around this other tube and then goes to the penis finally. That is a detour. It doesn't make any sense. No designer would ever have planned a detour of that kind.
The human eyeball is also kind of a design cock-up in your perspective.
The retina in mammals and fish, in all vertebrates, faces backwards, so that if you can think of them as photocells, the cells that are actually collecting the light are at the back of the retina, not the front of the retina. The front of the retina is occupied by all the blood vessels and nerves and all the sort of infrastructure, which clearly, if a designer had done it, would be at the back. I mean, you don't put the infrastructure and all the wires in the way of the light. You put it at the back. It's because of history. It happened to be the way it evolved originally. That's the way it's been ever since. There's been lots of tinkering ever since to, as it were, make good the mistakes after they're made. But any designer worth his salt would have simply said, oh, we'll start again and turn it round. The obvious thing to do.
Now, in Darwin's time, neither he nor any scientist really had any understanding of genetics or DNA in particular. How has that aspect of science changed the evidentiary base of evolution in the ensuing period of time?
It's changed it enormously. The DNA code is digital and it's universal. It's the same in all living creatures that have ever been looked at. And that means that you can take any two animals or plants you like and you can find recognizably the same genes. You can say there are minor differences, and you can actually count the number of differences.
It's scary how close we are to worms, for example.
Yes, and some genes are much more similar than others. There are some genes that the geneticists use the word conserve, that are conserved over the whole of the animal kingdom, for example. Other genes that change a lot. But so you can say this is the same gene in a worm as in a human, and you count the number of differences between them. You literally count the number of letters that are different in a piece of text. It is text, it's digital information, and you count it. Now, you find if you do that for one gene that you get a nice, pretty tree diagram. It's a pedigree, it's a family tree. That's the only sensible explanation for it. Then you do the same thing for a different gene, and another gene, and another gene, and you always find the same tree. It all fits the pattern of a family tree, a single tree of life, the one true tree of life. Now that is overwhelmingly powerful evidence for evolution. It even works for so-called pseudogenes, which are genes that have lost their function, that no longer do anything. They're just sitting there like relics of a chapter you once wrote sitting on your hard disk. They're still sitting there, and you can still read them, but they don't do anything. And yet even they show precisely the same tree when you compare the differences between one species and another.
You use the words time and time again, and I haven't noticed it in a lot of other work, is that it's non-random selection. Explain to me why that's important.
It's very important because the opposition to evolution very often comes from people who mistakenly think that it's a random theory. So they will think
it's
that
chaotic.
Yes, they will think that just because it's elegant and complicated and couldn't possibly come about by random chance, therefore it must have been designed. They think the only alternative to random chance is design and vice versa. Well, it's not. Natural selection is not random chance, and it's not design. It is non-random selection, non-random survival, the non-random survival of those organs, those genes which work.
Which are most adaptive to the environment that they're in at the time.
And it's extremely non-random. It's the epitome of non-randomness. If you seriously thought that the only alternative to design was random chance, well, of course you wouldn't believe in random chance. It would be completely dopey to believe that living things were the result of random chance.
And that's kind of where we started. For you, there is majesty in that non-random basis of natural selection. Expand on that just a little bit.
There's
more.
majesty because of what it achieves. It is the greatest show on earth. It's superb what has been achieved. There are mistakes, and they're interesting mistakes, but nevertheless, the grace of a swallow's wing, the elegance of an eye or an ear, a running limb. Think of a cheetah or an antelope that it's pursuing, these beautiful running machines. These are beautiful, elegant machines that have a powerful illusion of having been crafted, of having been designed, and yet it isn't. Yet it's come about by this unconscious, non-random, but nevertheless non-directed, unplanned mechanism. That is a staggeringly elegant thought.
You created a tremendous controversy with your last book, the God Delusion. Having done this one now, are you even more firmly of the view that those of us who believe that this greatest show on earth might have been set in train by some other being, a God-type being, are delusional?
Well, that doesn't come into the present book.
No, I know.
That was a theme of the previous book. So I don't deal with that. There are many people who do believe that, of course they believe in evolution, because you have to. I mean, the evidence is overwhelming. But they nevertheless think that some kind of higher power started the process off,
yes,
or something of that sort, and that's what you're now talking about. Well, I don't believe that. But that's not the subject of this book, and I don't actually discuss it in the present book. So if that's what you want to believe, then you'll find nothing to quibble about, nothing to disagree with in the greatest show on earth.
I want to finish on that note, because, I mean, clearly you had an agenda when you set out with the God Delusion. What do you want to accomplish in this book? What do you want to leave your readers and our viewers with?
Somebody who reads the greatest show on earth and takes it in will end up being totally convinced that evolution is a fact, that we are cousins of every living creature on Earth, some close cousins, some distant cousins, some very, very distant cousins, but we have a common ancestor with every other creature. They will end up, if they read the book in the way that I hope they will read it, they will end up completely convinced that that is a fact, as secure as any fact that we know.
Richard Dawkins, I want to thank you very much for joining me. It's been a real pleasure.
Thank you very much.